So listen. Here we are taking the oxidation method. In oxidation method, we are preparing the salts of non-metal. Salts of non-metal. There are 4 methods. They are prepared: iodine and selenium salt and sulfur salt, and will be prepared by oxidation method. Okay. Now next we are taking that is reduction methods. What is that? Reduction method. So preparation of salt, that is reduction method. So that we are taking the second method, that is reduction. Okay, listen. And what do you mean by reduction? By using reducing agents. By using reducing agent, that is the reduction process occur on addition of hydrogen. Addition of hydrogen or removal of oxygen is nothing but reduction. Now, in this reduction method, the salts of metal we may prepare. So, in this reduction method, we are prepared the salts of metals. The salts of metals. Salts of non-metal will be prepared by oxidation. Salts of metals will be prepared by reduction. So salts of metals like, that is silver and gold and platinum and copper, these are prepared. So salts of metal, that is silver, gold, platinum and copper, is prepared by the addition of non-metal, non-electrolyte. So we are preparing the salts of non-metal by the addition of non-electrolytes. What is that? Non-electrolyte. What do you mean by non-electrolyte? It cannot be split into ion, and it is known as non-electrolyte, like tannin. They are taking the examples of non-electrolyte like tannin. What is that? Tannin. And that is hydrazine. What is that? Hydrazine. So tannin and hydrazine. You know that the formula of hydrazine? Hydrazine is nothing but what is NH2 bond NH2. N2H4 is nothing but hydrazine. And phenyl hydrazine. What is that? Phenyl hydrazine. Phenyl hydrazine. So it is phenyl hydrazine, and phenyl hydrazine is nothing but that is C6 H5 NH2 NH2. That is phenyl hydrazine. C6H5 is known as phenyl group. So that we are taking, that is tannin, hydrazine, phenyl hydrazine, and formaldehyde. What is that? Formaldehyde. Formaldehyde. We are using tolerance agents, that is formaldehyde is nothing but that is HCHO are used. So that here we are preparing the salts of metals. Salts of metals like silver, gold, and platinum and copper by the addition of a non-electrolyte. A non-electrolyte is one on passing electricity cannot be split into ions like tannin, hydrazine, and phenyl hydrazine, and formaldehyde, and CO. What is that? CO. These are all non-electrolytes. Now we are preparing a gold salt. What is that? We are preparing a gold salt. Listen, in this we are taking, that is auric chloride. What is that? AuCl3. Auric chloride. Okay, but auric chloride is treated with formaldehyde. Formaldehyde is a non-electrolyte as are using for the reduction process, so that it is a formaldehyde, that is at CHO in aqueous solution, so that we are adding that water. So when RE chloride is treated with the formaldehyde and water, we are get that is a gold salt. What is that? AU, that is a gold salt. And the gold salt is considered as, that is the purple of Cassius, which is known as purple of Cassius. So purple of Cassius is nothing but the gold salt is adsorbed on stannic hydroxide. So the gold salt is adsorbed on stannic hydroxide, which is known as the purple of Cassius. So here we are preparing, that is a gold salt, and the byproducts are HCl, and formaldehyde is a reducing agent, so it will be get oxidized to formic acid, that is HCOOH. Okay, now we want to balance it. So here that is a chlorine. So that balancing is one, that is 2 molecules of AuCl3 is taken and 3 molecules of formaldehyde, and that is 3 molecules of water. 3 molecules of water. So that is here, that is gold, that is 2 molecules, that is 2 molecules of gold, and that is HCl we are get, that is a 6 molecule of HCl, and 3 molecule of formaldehyde is converted into 3 molecule of formic acid. So listen, this is the reduction process, and in this reduction process we are get, that is a purple of Cassius, purple of Cassius. And the same that will be prepared, that is auric salt, that will be prepared, or gold salt will be prepared by treating hydrazine. So by treating hydrazine, that is a 4 molecule of AuCl3, 4 molecule of AuCl3 is reacted with the hydrazine. What is that hydrazine? NH2 bond NH2. NH2 bond NH2. Okay, then it is 3 molecules of hydrazine. 3 molecules of hydrazine. Then we are getting the gold salt and nitrogen. That is 4 molecule of gold, 4 molecule of gold, and that is nitrogen. That is N2. So we are saying that is 3 molecules of N2, 3 molecule of N2. And that is chlorine and the hydrogen, so that here that is 12 molecule of HCl. So here we are treating, that is salt like silver or gold or platinum is treated with a non-electrolyte like tannin, hydrazine, and phenyl hydrogen. Then it is nothing but hydrazine, correct? It is hydrazine. So, and hydrazine or formaldehyde is treated with the salt of gold or silver or platinum or copper. We are getting, that is salt of the metal. So, metal salts are prepared by reduction process. Okay, and the next process, it is hydrolysis. So, listen, we are taking the next process, it is hydrolysis. So the third process, it is hydrolysis. Okay, what is hydrolysis? And hydrolysis is nothing but treating with water. Treating with water. Okay. In hydrolysis method, we are prepared, that is oxides and the hydroxide salts. Oxide and the hydroxide salts of heavy metal. So in this method, we are preparing oxides and hydroxides, oxides and hydroxides, hydroxide salts of heavy metal. Heavy metal. Listen, generally, a non-metal salts are prepared by oxidation. Metal salts are prepared by reduction. And hydroxide or oxide salts of heavy metals that will be prepared by hydrolysis. What is that? Hydrolysis. Now we are taking the reaction. The first one, that is ferric chloride on hydrolysis. So we are taking the ferric chloride. So here that is ferric chloride. Ferric chloride on hydrolysis. Ferric chloride on hydrolysis. So what will happen? Removal of HCl, then we get ferric hydroxide. Ferric hydroxide, that is FeOH thrice. Ferric hydroxide and that HCl. Ferric hydroxide and HCl. So this ferric hydroxide is a salt, hydroxide salt that will be prepared by hydrolysis. So by balancing the equation here, that is 3 OH is utilized, so that here it is 3 molecule of H2O and that will be removed of 3 molecule of HCl. 3 molecule of HCl. Okay, the same way we are preparing, that is chromic hydroxide salt and aluminum hydroxide salt. So here that is chromic chloride. What is that? CrCl3 is reacted with what? CrCl3, that is chromic chloride. Then we are getting, that is chromic hydroxide salt, that is CrOH thrice and removal of HCl. Removal of HCl. Okay, now it is balanced 3 molecule of water and the 3 molecule of HCl. So that here that is 3 molecule of water and 3 molecule of HCl that will be removed. The same way we are taking antacid. What is antacid? Aluminum and magnesium hydroxide. They act as antacid. So here the antacid, aluminum hydroxide that will be prepared by taking aluminum chloride. So aluminum chloride is reacted with 3 molecule of water. 3 molecule of water, we are getting aluminum hydroxide. Aluminum hydroxide and that is HCl and it is 3 molecules. So this is the hydrolysis method. So by hydrolysis method, we are preparing the hydroxides of heavy metals, that is D block elements, heavy metals, and aluminum is a P block element. Okay, so here oxides are hydroxides of heavy metal that will be prepared by hydrolysis. Okay, and the next method we are in, that is double decomposition. So what is that? The fourth method, it is double decomposition. So we are taking the fourth method, double decomposition. Double decomposition. What is double decomposition? Both of the salts are decomposed and they will be given new salts. And there is double decomposition. We are preparing the sulfide salts are prepared by passing hydrogen sulfide gas. So here we are preparing the sulfide salts. What is that? The sulfide salts. So the sulfide salts are prepared by passing hydrogen sulfide gas. Sulfide salt is prepared. Sulfide salt is prepared by passing hydrogen sulfide gas. Hydrogen sulfide gas through the cold solution. Through the cold solution of, we are taking a cold solution of AS2O3, that is arsenious oxide, and that is cadmium chloride, cadmium chloride, and that is mercuric cyanide. Mercuric cyanide. So we are taking the cold solution of this AS2O3 and the cadmium chloride and mercuric cyanide, and we are passing a stream of hydrogen sulfide gas. Stream of hydrogen sulfide gas. We are here, that is acidious sulfide, and only here the sulfide salts are proposed. Sulfide salts are proposed. So the reaction is here, that is acidious oxide. What is that? The first one we are taking, that is AS2O3. Acidious oxide is treated with hydrogen sulfide gas. Hydrogen sulfide gas. So acidious oxide is treated with hydrogen sulfide. Then we are taking the acidious sulfide. What is that? That is AS2S3, acidious sulfide and water. So acidious sulfide and water molecule. And here the acidious sulfide is a yellow salt. We are taking, that is a yellow salt. So this is a yellow salt. Now we are passing hydrogen sulfide gas through the acidious oxide. The yellow salt of acidious sulfide is formed. Now the intensity of the yellow color is maximized by passing hydrogen sulfide. So maximum intensity is attained, then we may stop the passing of hydrogen sulfide gas. So we are getting, that is acidious sulfide salt. To balancing it, we are taking, that is in product side, that is S3. So that we are taking, that is 3 molecule of H2S. So 6 hydrogen, so 3 molecule of water. So it is balanced. The same in cadmium chloride. So what is that? Here, the next one here, that is cadmium chloride. So cadmium chloride is passed with hydrogen sulfide gas. Hydrogen sulfide gas that we are getting, that is cadmium sulfide. Cadmium sulfide, and that is 2 molecule of HCl. So here this cadmium sulfide is your salt. Okay, what is salt? That is solid is present in your liquids. Okay, now we are getting the next one, that is mercuric cyanide is treated with H2S. So we are taking mercuric cyanide, that is HgCN twice. Mercuric cyanide is passing through the hydrogen sulfide gas. Hydrogen sulfide gas we are getting, that is mercuric sulfide. What is that? That is HgS, mercuric sulfide salt, and that is 2 molecule of hydrogen cyanide. 2 molecule of hydrogen cyanide. So these are the double decomposition method. Double decomposition method. So in double decomposition method, we are preparing a sulfide salt. So sulfide salt is prepared by passing hydrogen sulfide gas through the cold solution of acidious oxide and cadmium chloride and mercuric cyanide. Mercuric cyanide. Okay, and the next one we are taking decomposition. So the fifth reaction, it is decomposition. So we are taking decomposition. So what is that, a decomposition reaction? Okay, yeah, compound that will be decomposed into videos is constraint ion, then it is known as decomposition. Decomposition. And in this decomposition reaction, that is, we add few drops of acids. Few drops of acid to dilute solution of thiosulfate, sodium thiosulfate. So just we are adding few drops of acid is added. Few drops of acid is added Few drops of acid is added to dilute solution of thiosulfate. To dilute solution of thiosulfate. So we are adding an acid to dilute solution of thiosulfate. The insoluble free sulfur is formed. So here the insoluble. So here few drops of acid is added to dilute solution of thiosulfate, and the insoluble sulfur. So here the insoluble sulfur is formed and accumulated into small clusters. So insoluble sulfur is formed and accumulated into small clusters. Which impart the color. So the small cluster which impart the colors, like blue and yellow and red. Blue, yellow and red color. So here we are passing a few drops of acid to the dilute solution of the sodium thiosulfate. The insoluble sulfur salt is formed and it is get accumulated into a clusters, and which impart color like a blue color or yellow or red, and it is depending on the size of a colloidal particle. Is depending on the size of the colloidal particle. So various size of a colloidal particle that will be produces various color. So here we are prepared, that is blue color and yellow color and the red color. So we are taking the reaction, that is sodium thiosulfide. So here the thiosulfate, that is nothing but Na2S2O3. So we are taking the ionic reaction, that is thiosulfate is nothing but S2O3 2 minus. So it is a thiosulfate ion. We are adding that is H plus, that is acid. So acid is added to thiosulfate, that will be found a free sulfur. We are taking that is a free sulfur, and this is a salt. So sulfur salt, and maybe the blue or yellow or in red color, and from that the byproduct, that is H2O and that sulfur dioxide. So 2H plus is added. So this is the decomposition reaction. When sodium thiosulfate is reacted with the H plus, then we may get the sulfur salt and the water and the sulfur dioxide. And also here we are taking one more decomposition reaction, that is nickel tetracarbonate. What is that? This is the nickel tetracarbonate. It is on heating, it will be decomposed into the metal salt, that is nickel salt and 2 molecule of carbon monoxide. So nickel tetracarbonate on decomposed, we may get nickel salt. Okay, so these are the chemical methods. So what are the chemical methods? So we are saying, listen, we are taking the chemical methods of preparation, that is colloids, that is oxidation. What is that? Oxidation and reduction and hydrolysis and double decomposition and decomposition, and that is these are the reactions. Okay, so we may revise first. These are the chemical methods of preparation of colloids by condensation method. So first we may take what is condensation. That is smaller particle. What are smaller particle? Like atom or molecule or ion, which is converted into colloidal size. Then it is 10 to 200 nanometer. Then it is known as condensation method. Okay, so here the first method, that is oxidation. In this oxidation, we are preparing salts of non-metals. Salts of non-metals. So salts of non-metal that will be prepared by oxidation. So iodic acid. What is iodic acid? Is nothing but HI3. So iodic acid is reacted with the hydrogen iodide. We get iodine salt. And the next, hydrogen selenide. Hydrogen selenide is reacted with the oxygen. We make it, that is the selenium or selenide salt. And here hydrogen sulfide is oxidized by oxygen or chlorine. We are get the sulfur salt. And the next reduction. In oxidation, we are preparing the salts of non-metal. And in reduction, we are prepared the salts of metals. Salts of metal like gold, silver, platinum, and copper by addition of the non-electrolytes like tannin, hydrazine, phenylhydrazine, and formaldehyde. Now we are getting the gold salt, that is percolaceous, by treating gold chloride with formaldehyde or maybe hydrazine. Now the third one, we are getting hydrolysis. So what is hydrolysis? Oxides and the hydroxide salts are heavy metal that will be prepared by hydrolysis. Okay, so here we are saying ferric chloride is converted into ferric hydroxide by hydrolysis, and the chromic chloride is converted into chromic hydroxide, and the aluminum chloride is converted into aluminum hydroxide. So here the hydroxide salts are heavy metal that will be produced by hydrolysis method. The next, double decomposition. In this double decomposition, we are preparing a sulfide salt by passing hydrogen sulfide gas through the cold solution of arsenious oxide and cadmium chloride and mercuric cyanide. We are getting the sulfides of arsenic, cadmium, and mercury. Then the next decomposition reaction. In this decomposition reaction, we are taking, that is sodium thiosulfate. So what is that sodium thiosulfate? Na2S2O3. And here we are taking S2O3, that is thiosulfate ion. Is reacted with acid, then it will be produces the free sulfur, and the free sulfur is accumulated as a clusters. Free sulfur is accumulated as a cluster, and which impart a color depending upon the size. It may be blue or yellow or red. And nickel tetracarbonate on decomposition, we are getting nickel salts. Okay, the last one, that is the physical method, that is exchange of solvent. So we are taking the exchange of solvent. Exchange of solvent. And in this method, here we are preparing, that is sulfur or phosphorus salt. So we are prepared the colloidal solution of phosphorus and sulfur salt. Phosphorus and sulfur salt. So here we are saying this phosphorus and the sulfur salt is insoluble in water and soluble in alcohol. So that we are saying this phosphorus in alcohol is taken. Phosphorus in alcohol. So what happened? Phosphorus is completely dissolved in alcohol. Then we are adding a water here. And here water, phosphorus cannot be easily dissolved with the water. So here we are taking phosphorus in alcohol by adding water. Then it will be prepared that is phosphorus salt. Phosphorus salt. So the same way we may prepare the sulfur salts also. So here we may exchange the salt. That is, the solvent alcohol is replaced into water because the solubility of phosphorus is maximum in alcohol but minimum in water. So by exchanging of the solvent, we may get the salts. So these are the condensation methods to preparing salts. So listen, students. Students, are you hear my words?
Yes, sir.
Taking condensation. And in these condensation methods, the metal salts are prepared by what method? Metal salts. How will you prepare a metal salts? Oxidation or reduction or hydrolysis?
Reduction. Reduction.
Reduction. And what is purple of cations?
Gold salt.
Gold salt is adsorbed on stannous hydroxide, which is known as purple of cations.
Purple of cations.
And by oxidation method, which type of salt is prepared?
Non-metal salts.
That is salts of non-metal.
Non-metals.
Okay. Then we are taking in hydrolysis. We are getting the antacid. What is the antacid?
Aluminum and magnesium hydroxide.
Magnesium hydroxide. So the mixture of aluminum and the magnesium hydroxide is nothing but antacid. Do you know that is Gelusil?
Yes, sir.
Yes, Gelusil is made up of these two. What is that? Aluminum and magnesium.
Magnesium hydroxide.
Aluminum and magnesium hydroxide. Okay. Now we are getting the sulfide salt.
Double decomposition method.
Very good. That is double decomposition.
Double decomposition.
So by double decomposition method, we are preparing that is arsenious sulfide and the cadmium sulfide.
Cadmium.
Mercury sulfide. Correct?
Yes, sir.
Okay. Now we are taking the reduction process. What are the non-electrolyte state? What is the non-electrolyte?
Tannin, hydrazine, phenylhydrazine, formaldehyde.
Tannin,
Hydrazine, phenylhydrazine,
formaldehyde. Phenylhydrazine, formaldehyde.
whether it is hydrogen or hydrazine.
Hydrazine.
Hydrogen means it is H2. Hydrazine means it is N2.
NH2 bond NH2.
NH2 bond NH2 is nothing but N2H4. N2H4.
N2H4.
And you know that the formula of urea, which is the first compound prepared in laboratory. The first organic compound that will be prepared in laboratory is urea. You know that the formula of urea? Now, what is the formula of hydrazine?
N2H4.
NH2 bond NH2.
NH2.
We are adding one CO group, that is carbonyl group, then we are getting urea. NH2 CO NH2 plus. So what is the formula of urea? NH2
NH2 CO NH2.
NH2 CO.
NH2.
Not CN, it is CO.
NH2
CO.
Yes,
Yes, sir.
NH2 CO NH2. So between 2 NH2, we are adding CO, then it is nothing but urea, the first organic compound that will be prepared in laboratory. Okay. Now we are doing hydrolysis method. And by hydrolysis method, which type of salt is prepared?
Salts of oxides and hydroxides
Salts
of
of
heavy metals like chromium, aluminium.
chromium and aluminum.
So, salts of oxides and hydroxides that will be prepared by hydrolysis method. Hydrolysis method. Okay. Now, we are getting that is nickel salt. Where we are getting a nickel salt in
Decomposition method.
very good. That is
Decomposition method.
And further, we are getting nickel tetracarbonate. That is one
Tetracarbonate.
nickel tetracarbonate. And in nickel tetracarbonate, what is the oxidation state of nickel?
4.
Oh, this is not oxidation state, listen. And it is a special compound. This is not an oxidation state of this CO. So here in nickel tetracarbonate, the oxidation state of nickel is 0. What is that? The oxidation state of nickel in nickel tetracarbonate is 0. Refer D block. Okay. So in D block, we are taking nickel tetracarbonate as a complex, and the oxidation state of nickel in nickel tetracarbonate is 0. Okay. Now, there is exchange of solvents. Exchange of solvents. And in exchange of solvent, which type of solvent will be prepared? That is phosphorus and sulfur.
Phosphorus and sulfur.
Exchanging the solvent, that is phosphorus in alcohol, is added with water. We are getting that is the phosphorus salt. Okay. And any doubt in condensation method?
No, sir.
No, sir. Very important those in and in your book, in your state book, only few reactions are given. So take a notes and I'm giving the maximum reactions in condensation method. Okay. Thank you, students.
Thank you, sir.
Thank you, sir.